Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Luthfia Noor Azizah with student ID number 24143035, majoring in Refinery Mechanical Engineering, and I'm very excited to present to you an interesting topic, which is how does an elevator work? Elevators are part of our daily lives, especially in tall buildings, skyscrapers, and any other building. But have you ever wondered what mechanical system and principle allow them to operate safely and efficiently? In this presentation, I will explain the basic component of an elevator, how the lifting mechanism work, and safety features that are critical for its operation. I hope this presentation will give you a clearer understanding of technology behind elevator. So without any further ado, let's get the roll begin. First of all, I'm gonna explain about my outline presentation. First is introduction, the second one is elevator history, and the third is basic component of elevator. The fourth is two types of elevators. The fifth is elevator safety, and the last is conclusion. Okay, let's begin with introduction. Elevators is a vertical transportation device used to move people or goods between different floors of a building. It consists of a cabin or platform that travels up and down along a shaft, powered by electric motors or hydraulic system. Elevator play a vital role in modern architecture, especially in high-rise building, skyscrapers, and another building, by providing quick and convenient access to various levels. The invention of the safety elevator by Elisha Otis in the 16th century greatly improved their reliability, making them an essential part of daily life in homes, offices, shopping centers, and more. Next is elevator history. Let me explain to you guys how does elevator inventor. Okay, in the 1060s, uh, architects and engineers were pushing boundaries of how high they can build. These buildings are increasing in height. There was somewhat of a limit. It was hard to utilize the upper floor because we had to walk up a lot of stairs. And no one really wanted to do that every day, right? Because we can get tired easily because that building is so many of high floors. And then, the elevator is not a recent invention. The idea of using machine to lift things in the air, this is not a new idea. It can be traced back to ancient civilization over 200 years ago. Various lifting devices such as hoists and cranes are already invented, but lifting people that usually wasn't done. So that's why Alicia Otis, best known for inventing the safety elevator in 1852, he developed a safety mechanism that prevented elevators from falling in the hoisting cable broke. His invention used a spring-loaded braking system that would automatically engage and lock the elevator car in place if the cable snapped. He famously demonstrated his invention at 1854 New York World Fair, where he stood on an elevator platform and had the roll caught in front of a live audience. The platform dropped slightly and then come to an immediate stop, providing the effectiveness of his safety devices. This breakthrough made the elevator such more safer and led to their widespread use in buildings, paving the way for development of skyscrapers. So, Alicia Otis are paving the way to use elevator into skyscrapers, so it make our life easier. So thanks to him. Next is elevator history, which is this is our the invention that um, Alicia Otis mm, Alicia Otis demonstrated in New York World Fair in 1854, like this. So it is using a rope here, and this is mechanism like lift spring in here and pivot arms. So if the pivot arms in the side of the lift elevator, they have a teeth. So if the cut the rope, it will automatically goes to the teeth, so it won't make us drop if the rope cut it, like this. This is how does Alicia Otis first invention in 1852 and demonstrated in uh, 1854. So they cut the rope, and Alicia Otis doesn't drop because the pivot arms. Next, we'll continue to the basic component of elevator. So, basic component of elevator is the first is hoseway or shaft. Shaft is a vertical passage that houses the elevator car and counterweight. Included guide rails to keep the car moving straight and safely. Second one is elevator cabin. This is a basic compartment that carries passengers or goods, designed for comfort, safety, and aesthetics. Next is motor and drive system. These are the powers of the movement of the elevator. Two common types of the motor and drive system is traction system, uses rope and counterweight suitable for high-rise building, and the second one is hydraulic system, uses fluid pressure, ideal for low-rise buildings. Next is counterweight. Counterweight is balances the weight of the elevator car, reduces the load on the motor, and improves energy efficiency, mainly in traction elevators. So basically, counterweight is mostly can we saw at the traction elevators other than hydraulic system elevators. Next is controller. Controller is the brain of the elevator system. Manage operations such as stopping at floors, door opening and closing, and safety protocols. Next is guide rails. Guide rails is metal tracks that guide the elevator car and counterweight in the hoist. And then next is door. Door is to set car doors on the elevator and landing doors. Doors is synchronized to open and close together safely. Next is safety devices. Safety devices include brakes, emergency stop switch, speed governors, and buffers. Elisa Otis safety brake is a crucial safety invention to prevent falls in the cable fails. As we can see at this slide, this is the safety protocols that Alicia Otis first invention. We cannot go there again, so we just can move. So this is the basic component of elevator. So this is the doors, and then this is the basic component of the elevators, as we can see, like this. So this is how actually elevator works. This is the shaft and hoistway, and then elevator pit. So basically, and cabin. So basically, this is attraction of elevators because this use a rope, guide rails, and then this is guide rollers. Next, we can go to the two types of elevators. As I said before, elevators has two types. The first one is the traction elevators, and the second one is a hydraulic elevator. So, uh, okay, and I already read that. So let's move on to the traction elevator. A traction elevator is powered by electric motors and use steel ropes or belts to move the elevator car up and down. How it works? The ropes are attached to the elevator car and pass over the drift shaft connected to a motor. A counterweight is used to balance the car weight, making it more energy efficient. Type of traction elevator is gear traction, which is use a gearbox suitable for mid-rise buildings, and gearless traction, direct drive system used in a high-rise building like skyscrapers due to high speed and efficiency. So we don't want to be like we're in elevators but it will be slow, so we have to use gearless traction so it will uh, make our time more efficient. The advantage is traction elevators is more faster and smoother operation. It's suitable for tall buildings, and the last is energy efficient, especially with counterweight. And the disadvantage of traction elevators is more expensive installation and requires a machine room. Next, we move to hydraulic elevator. A hydraulic elevator is use fluid pressure, usually oil, to move the elevator car up and down. How it works: a hydraulic pump pushes fluid a cyber into a cylinder that moves a piston, lifting the elevator car to descend. The fluid is released slowly, lowering the car smooth. Types of hydraulic elevators. The first one is conventional hydraulic, is usually use an underground cylinder, and hole-less hydraulic uses side-mounted piston, no deep pit needed, and robot hydraulic combines rope with hydraulic power for longer travel. The advantage of this hydraulic elevator is lower installation costs and ideal for low-rise building like just for two and until six floors. And the last one is machine room can be placed at the ground level, so we don't have to make a um, room for the machine room like traction elevators. The disadvantage is lower speed compared to traction elevators. As I said before, the traction elevators is more efficient at speed, so we can uh, make energy more efficient. And yeah, as I said before, hydraulic elevator is less energy efficient. And the last one is limited to low rise application. Next to elevator safety. So, elevator safety is a critical aspect of elevator design, operation, and maintenance. Modern elevators are equipped with various safety features to protect passenger and ensure smooth operation. First is safety brake system. This safety brake system first invented by Alicia Otis in 1852, like automatic stop the elevator in the hoisting rope brakes. Use mechanical arms or clamps that grip the guide rails. Next is speed governor, a device that monitors the speed of the elevator. If the car moves too fast, the governor triggers the safety brake and prevents overspeed accident. Next is door interlocks. Ensure elevator doors stay closed while the car is moving and prevents the elevator from operating if any door is not properly locked. Next is protects passengers from falling into the shaft. Next is buffer spring, located at the bottom of the shaft, act like shock absorbs to slow down the elevator in case of free fall or emergency. Next is emergency alarm and communication system. Inside the elevator, there's a sign like a like a bell, emergency button to sound an alarm. So that maybe there's engineer we can help us if we push that button, because if we push that button, the button will make sound, so people in the out of elevator can hear us. Next is intercom or phone system connects passengers to buildings care security or rescue service. Next is overload sensor. Is basically like a main compartment of overweight, so it will detect if the weight inside the elevator exceeds the maximum limit and prevent the elevator from moving until the extra load is removed. Next is fire emergency system. If the elevator are programmed to return a specific floor and remain there during a fire, prevent use of elevator in dangerous condition. Elevators should not be used during fire emergency unless there are firefighter in elevators. Next is regular maintenance and inspection. Elevator must be inspected and serviced regularly, like by certificate technician, prevent mechanical failure, and extends the lifespan of the system. And the last is ensures compliance with local safety regulation and standards. Next is conclusion. So, the conclusion, elevators are a vital system in modern building, enabling safe and efficient vertical transportation with key components like the elevator car, motor, controller, and door mechanism. They function smoothly and reliable. The two main types, traction and hydraulic elevator, serve different building needs. Modern elevator also prioritize safety with features such as speed governors, door interlock, and an emergency system. Thanks to ongoing innovation and proper maintenance, elevators today are not only efficient but also among the safest modes of transport in buildings. And we also have to say thank you to Elisha Otis who invented the elevator at 1852. All right, I think that's all my presentation today. Um, thank you so much for your attention. I'm Luthfia Noor Azizah. Wassalamualaikum warahmatullahi wabarakatuh.